Yeah. So we studied following things in two-port network. One is called Z parameter and one is called Y parameter. Moreover, we also learn two kinds of network. One is called T network and one is called pi network. Is there anybody who hasn't seen T and pi network, or everybody knows? Okay, so what about this network? What should I call this one? Right? This pi network, right? So we studied these things. Apart from that, Z parameter is the one where V1 and V2 are dependent parameter, and the governing equations are as follows. Where Z11 is nothing but V1 by I1, where I2 equal to 0, and Z12 is equal to V1 by I2 when I1 equal to 0, and others are also can be written on the basis of this. So such kind of Z parameters are found by keeping one of the current as 0. We call such Z parameters as open circuited parameters. Similarly, for Y parameters, where V1 and V2 are considered as 0, so such kind of parameters are known as short circuited parameters. We also tried some of the questions on different networks. We found if the network has only two mesh equations or only two nodal equations, it's very easy to find out its Z and Y parameters, right? So it's not a problem to find out Z or Y parameter. However, if it is not having two mesh equations or two nodal equations, if there are more number of equations, then you should use some technique called delta, where delta is nothing but a determinant, and let's assume that you want to find out Y parameter. Y parameter is defined as like Y11 is defined as delta 11 divided by delta Y12 is equal to delta 21 divided by delta Y21 is equal to delta 12 divided by delta, and delta 22 Y22 is equal to delta 22 divided by delta, where all delta like just delta are determinant, and delta ij is nothing but you need to remove a particular row and column entry, and afterwards whatever the delta is, whatever the determinant is left, just you need to find out determinant multiplied by minus 1 raised to I plus j. So if both the positions are odd, then you have to multiply that one with plus 1, or if it is odd, then it will go to minus 1. So that is what we have done, and this is very important when you want to solve a bigger circuit where you may have more number of nodes or mesh equations. If that is the case, you can solve those things very easily. So that is what we studied. Now there is one more thing. Let's look at Y parameter in terms of Z parameter. You can derive different parameters in the form of, let's say, Y in form of Z, Z in form of Y, or other parameters which we are going to study. So they can be derived with other parameter. So let's assume that you want to derive Y parameter in the form of Z parameter. So how it will look like? So still I am following same book, Excuse me, you are not allowed. Yeah. Thank you. So if you are having a pi network where three admittances are there, YA, YB and YC, and there are two currents I1 and I2 and two voltages V1 and V2, then you can write down the equations I1 and I2 in the form of admittances as follows, right? This we have already done. Oh. So it's not about Y and Z, sorry. So if it is symmetrical network, then Y11 equal to Y22 and Z11 equal to Z22. This is not true for all the circuit, by the way. This first highlighted box is not true for all the RLC circuit, but Y12 is equal to Y21 and Z12 is equal to Z21. This is true for all RLC circuit, and this kind of network is called reciprocatory network. By the way, as I told yesterday, we have workshop tomorrow. If you want to attend that, the cadence workshop, right, for 3 days. It's from morning to evening, or at what time it is? Where? So PC Lab, South Campus, from 9 a.m. to, oh, tomorrow is from 11 to a.m. to 5 p.m. This is cadence workshop. So cadence is only one company, or it's an EDA company who is making all the circuit simulators. It's only one company in the world which is being used for making the ICs. Do you know IC? Integrated circuit, black colored IC. You must have seen something like this. Something, right? You must have used it, right? So how to make this IC inside like this black box? That is the whole study known as VLSI, very large scale integration, and all VLSI people are using only cadence, right? It's a starting point for circuit designing, analog or digital, anything. Even if you are designing processor, you have to design it in cadence. So if you want to learn it, come tomorrow, right? 3-day workshop. It's free of cost. Generally, one license is 1 crore, right? So, but we got some cheaper price at the university program. We have 45 license. Sorry? Monday is also. But if you like on Saturday, then you should think about Sunday. If you like Saturday, Sunday, then you can come on Monday, right? If you like it, I can talk to your professors not to take your lecture, but you should be there in our workshop. Okay, so we studied symmetrical and reciprocatory network, and they are depending on their Y parameters and Z parameters. Okay, there is new class of parameter. One is known as H parameter or hybrid parameter. This parameter does not have like earlier case we had only voltages as dependent or current as dependent. Here it's a hybrid. So sometimes voltage is dependent, sometimes current is dependent. So in the first equation, voltage is dependent quantity. In the second equation, current is dependent quantity. And I1 and V2 are actually independent one in hybrid parameter. And they are defined as V1 is equal to H11 times I1 plus H12 times V2, and I2 is equal to H21 times I1 plus H22 times V2. So H11 is nothing but V1 by I1 when V2 equal to 0. This is V2 equal to 0, that's why we are going to call this one as short circuited parameter. And H12 where it's V1 by V2, it's I1 equal to 0. This is open circuited parameter, and H12 is nothing but V1 by V2. So if V1 is input and V2 is output, which is generally the case, then H12 is nothing but 1 by transfer function, right? So sometimes back, Nivanshu was asked me in the canteen why we are doing all these things, right? At the end, we want to know that how my circuit performs. Or let's look at his question. His question is why we are doing all these things. So doing all this analysis, I can find out how my system or my circuit will behave. So for behavior, I may have following things. I can look at the transient, I can look at frequency, I can look at pole 0, right? Or I can look at DC analysis, right? Through which I can find out whether my circuit will work as per my requirement or not, right? So to have all these things, I need to have the transfer function or its equivalent model of my circuit, how circuit is behaving on the basis of the applied current or voltage, and on the basis of that I can find out all 4 of them or maybe some more things also. So for that we are doing all these things. So H12 is nothing but it's giving me a transfer function which is 1 by transfer function, and that was the reason why in the earlier time this H parameter was very popular, and people were only using H parameter for analyzing any circuit. H parameter was the most popular one earlier time because it was giving me transfer function. One place is it's also giving transfer function in terms of voltages, transfer function in terms of current also. So sometimes if it is current control current devices, then you can see that H21 is actually the ratio of two currents where V2 equal to 0, although it's short circuited parameter, but it's the ratio of two currents. So it was also very popular thing when I want to find out the current gain. Similarly, like V2 by I2 or V1 by I1 can be found out by H11 and H22. This is going to give me H11 is V1 by I1. So what do you think, what should be the usage of this one? This one is giving me transfer function in voltage. This is giving me transfer function in current or the current gain, voltage gain. What about this one, V1 by I1? What information I am getting? So input impedance, right? And this one is giving me output admittance or 1 by output impedance. So you can have all the information because I wanted to know what is input impedance, what is output impedance, and what are the transfer functions, so that I can see the behavior of my circuit. So that's why H parameter was very popular, but afterwards people found that Y parameter is much easier and much handy to use it. That's why people are using Y parameter also. So if you're reading old books which has been written before 2000, then you can see H parameter is dominant one. But the new books, they are talking about Y parameters.
But to find such type of equations which involve both voltage and current on the same side, we need to perform KCL and KVL both.
Yeah, you can use any one of them. Okay, maybe you missed like previous lecture where, so there are 3 different techniques. One, you can write down the equations, and one is by inspection. You remember, you were there? Okay, that's why you are saying that. So we spent something like 2 lectures on inspections. So by inspection you can say that, but still you need to write down KCL, KVL. There is no other option. KCL and KVL will be there for sure. You have to be expert of mesh and nodal equations, right? So generally what we are doing, if it is short circuit, we are short circuiting particular value of voltage, and then we are checking what is V1 by I1 or V1 by V2, right? I can give you one example. This was the previous example we solved. So if this is V2 and if this is V1 and there is current I1. So if I want to find out, let's say V1 by V2 when I2 equal to 0, can you tell what will be the value? So I2 is 0 means this is open circuited, right? This has to be open circuited. Now, can you write down V1 in terms of V2 or V2 in terms of V1? Yeah, Amol. No, you just look at this and tell me. It does not require lots of effort. Can't you see any relation between V2 and V1? For you, let's make this network easier. So this is V1 and this is R3, R2. Yes, Gaurav. V2 is equal to? Okay. Whichever way you like, you can do that. I generally write this way. This is a voltage division. Look, Amol, this is just a voltage division where R1 is not playing any role because it's connected with respect to ground, right? Okay. So this way you can find out V1, V2. You don't need to go through the whole equation of the entire circuit. By inspection you can find out for different cases of V1, V2, or you have to make V2 equal to 0 and I1 equal to 0. You can go to my previous lecture or maybe two previous lectures where I solved that. Even it's recorded one. Okay, so that way we have H11 is equal to 1 by Y11 and H22 as 1 by Z22. These two parameters are known as short circuit current ratio and open circuit current ratio. This is short circuit current ratio because V2 equal to 0, open circuit because I1 is equal to 0, right? And H21 is giving me I1 by I2, I2 by I1, and one is giving me V1 by V2. So these, one of them is current ratio and one of them is voltage ratio, right? So now you have to find out 4 different parameters. Can you find out that by inspection? So first one I found out, but can you get same or not? H11 is equal to what? Is it open circuited or short circuited? Right? Yeah. So this is the equation we have. So can you connect V2 equal to 0? So V2 goes to 0. Then apply whatever maths you want to apply. The answer is already given to you, but you have to find out. Nakul, can you find out in your notebook? Please do it in your notebook, otherwise you will never learn it, right? So V1 in terms of I1, I can write down directly, no? So I can see V equal to, there are 2 branches of currents. I can club them together if I want. So there are two resistances are in parallel. Look, there are two resistances in parallel. One by. Are you getting same answer, or Manpreet? Yes or no? No. Then look, it's there are two resistances. One by YA, one by YC. They are in parallel. Times I1 is going to give me V1, right? So V1 by I1 is equal to parallel combination of these two. So how much? What Y? Admittance, yes. So that's why these two resistances are in parallel. So 1 by YA times 1 by YC divided by 1 by YA plus 1 by YC, which is going to give me 1 by YA plus YC. Yeah? Yeah. So if you understood this, to be confident on all these analysis, you need to do the analysis. Now, can you do, let's say, H22? That might be easier one, right? What is H22, by the way? Hmm? V2 by I2, I2 by V2, right? Because that is 1 by Z22. H22 is 1 by Z22. This one is 1 by Y11, right? So Y11 is V1 by I1 by V1. Z22 is V2 by I2. So it's I2 by V2 when I1 0, because this is open circuited parameter, right? Because this is the most important part. Otherwise, Y22 is also look like this one, right? But it's V1 equal to 0. But we are not choosing Y22 because it's I1 equal to 0. So it looks like Z22. So I1 equal to 0. So let's make this one open circuited. If you want to find out such thing, then you have to use V1 in terms of V2, right? If you have V1 in terms of V2, then you can find out those things. Okay, here it's not required, sorry. V2 by I2 will be very easy. Without knowing other things, you can find out. And look at the resistances. Look, there is no current. That's the only thing. The current major source is I2. This is V2 and this is V1. Forget about I1. Even you can forget about V1. There is series connection of two resistances which are 1 by YA plus 1 by YC in parallel of 1 by YB times I2 is going to give me V2. So can you find out now in your notebook? Right. It's simple, right? You are not doing, that's why you are not becoming confident. You should solve this. Yeah, Divanshu, are you following? Okay. So what is the answer you got? H22 is equal to So these two are the transfer functions by the, sorry, yeah. These two are the impedances. One is input impedance and one is output impedance. So we found out input and output impedance. Look, right now the technique is not with them. We are using something different technique to find out input and output impedance. So somebody got the answer? Vaishali? Am I doing correct or this is correct till now or no? Okay, divided by, okay, plus YBYC plus YAYC. This is okay.
So the denominator will be
Let her try. Look. Okay, very simple. Okay, we will reveal the answer maybe at the end because S22 is the last one. Okay, so this is inverse of this one, huh? Somebody put, okay, yeah. So now H21, H21 is voltage ratio or current ratio? Current ratio. If it is current ratio, then find out the current ratio. Is it current ratio? Yeah. You can write down the equation. Yeah, you have to remember these. If you remember this, look, Nakul. So generally, like when I used to study, and so when I used to study and the exams were not open book, I used to write down at the back as a rough work. Before starting the exam, I was writing all these equations. Right? Z parameter is very easy, right? Y parameter is also very easy. But H parameter, which is hybrid one, where you have to remember V1 and I2 are dependent one, others are independent. You can write down this equation afterwards, it's easy, right? So I1 is nothing but I2 divided by, sorry, S21 is I2 divided by I1 when V2 equal to 0. So this is short circuit or open circuit parameter. H21 is open circuit or short circuit? Short circuit. Why? V2 is 0, right? So because you are, when V2 equal to 0, it's short circuit, right? Similarly, S22 is open circuited, right? So I2 divided by I1, you need to find out two ratios of current. Look, both the currents are available when V2 equal to 0. So when V2 equal to 0, this goes to 0. Then you have to find out I1 and I2. Still I2 exists, by the way. This is 0, but still I2 exists. This is a technique called solving circuit by inspection. Similarly, V1 and V2 are easy, right? We already found out V1 and V2. Right? That is easier one. So can you tell me the voltage ratio? V2 by V1. Oh, sorry. Yeah. So it's H12 is V1 by V2. Where is it? Yeah. So I want to find out H12, which is V1 by V2 when I1 equal to 0. V1 by V2, Amol. This has to be easy, right? Now? Yeah, V1 by V2. Yeah, when I1 is equal to 0. I'm asking you because similar thing we have solved. You will encounter only two kinds of circuit. Either it will be T type or maybe Y type. If you are encountering Y type, if you are following Y parameter is good for pi generally. and Z parameter is good for T. So it's up to you. You can transform. If you confuse some place, then you can convert this T network to pi network by delta to Y or Y to delta, right? Star to delta, delta to star. That is also another name, right? If you are expert of one kind of circuit, you can convert it to other one. But at the end of the day, you will have only two kinds of circuit, either T or either pi. So what Vaishali was showing, it's similar to that, but I don't know. It is exactly same or not. Sahi hai, right? So YA YB plus YB YC plus YA YC divided by YA plus YC. So inverse of that, that's what you gave me. So that's correct one, no problem. This is also correct, no problem. H12 is also no problem, right? The ratio. Amol, are you getting same answer or different? What about this one?
So that is common in all cases, no? That 1 2 is 1 2 and 2 1 are equal.
Yeah, but that is the case for Z parameter. Till now we have not derived anything for. So Z12 is equal to Z21, Y12 is equal to Y21. This kind of circuits are known as reciprocatory circuit, but for the H parameter, H12 is equal to minus of H21. Right? So directly you can keep the answer and you can check afterwards. So generally if it is RLC circuit without dependent sources, yeah, Amol, do you know what is dependent sources or no? Okay. Is there anybody who doesn't know what is dependent sources? Divyanshu, do you know what is dependent source, right? So if in your circuit there are some dependent sources, then this will not follow. If there is no dependent source, all the independent sources with only RLC, but there is one more extra circuit which is known as gyrator. We are going to define it before completing this chapter. So gyrator is also one of the popular circuit and similar to what you have studied in transformer. Right? So if it is there, then this is not happening. Otherwise, all RLC circuit, this follows these notations. Right? You will have always same answer. You must have experienced similar thing in when you are writing Z matrix and Y matrix, right? So upper triangular and the lower triangular both were same, right? In admittance matrix and impedance matrix. If you are writing H matrix, which is hybrid, then you will have minus side is like lower triangular will be minus and upper will be plus. Right? Okay. So now I want to find out Z in terms of Y. For same circuit where YA, YC, YB, you can replace this with some real components like RLC. But you should only replace with R, L and C only, not independent sources. If there are there, then you will not get these three things. There will be some answers, but these will not be matched. Okay, so either you can write down through admittance or I'm following maybe let's say delta technique. Then what I'm going to see at this node.
Sir, just now you said that if it is in expressed in admittance form, then only that trick works.
Which
That H12 is equal to minus of
H21 when everything is RLC.
RLC.
RLC. Okay. So all these three valid when this is RLC based circuit. If there is any confusion, please let me know. Because I was solving with other independent sources, but I was not getting the answer. But I tried for all RLC circuit. Even I looked at other books and found all RLC circuits are following these equations. Even many places, many people have said that all RLC circuits. That's why I'm quoting them. I'm saying that all RLC circuits are going to follow this particular relationship, right? So now I want to find out Z in terms of Y. So you have to, can we write down Y11, Y12, Y21 and Y22? Let's forget about this. Just for practicing, can you write down these four? By inspection, by delta, by whatever technique you want to follow, whichever is the fastest one, you can use it. Whichever you think that you are expert of, you can use it, right? So Y11 is nothing but V1 by I1 when I2 equal to 0. Sorry, I1 by V1, right, when I2 equal to 0, right? This one is I1 divided by V2 when, I made mistake, or it has to be V2 equal to 0, and this one is V1 equal to 0, right, because this is short circuited. Yeah. And similarly this one you can find out I2 divided by V1 when V2 equal to 0, and this one is I2 divided by V2 when V1 equal to 0. So what is I1 by V1? When V2 equal to 0. YA plus, okay, that much only, or what about Y12?
This Y plus YC comes only when we assume that one dash is at zero potential.
One dash, which dash?
One dash, that point one dash.
It's lower or the lowest potential. It's coming at lowest
there are
potential.
two grounds in the same circuit.
Okay. So lowest potential means may not be ground, but generally in this technique we consider that this is like this is ground and this is also some lower potential or near to 0.
Their assumption is always
Yeah. Right. Okay. So, but this might not be the case every time. Right now it's working because we have not considered this one some other potential. If it is connected to some other potential, then we have to consider that one also. We'll take those kind of examples, don't worry, right? So we'll have one complete lecture on just problem solving, right? We'll be having one tutorial class. Please attend that, Nakul, on time, right? Okay, so now y12 minus yc, this has to be minus yc. Okay, so now everybody are expert of this, so tell me, yb plus yc, huh? So this example has been solved by, okay. So if I want to find out z in terms of y, I can write down these equations or I can write down the matrix, right? So if I am having the matrix which is ya plus yc, and this side minus yc, this side minus yc, and this is, right, this is my impedance matrix, by the way. This is impedance matrix, and I can find out delta as ya times yb plus, I can write down this. This is determinant of this one, right? Similarly, I can find out delta 11 is equal to ya plus yc, delta 12, sorry, by delta y has to be there, right? It has to be yb plus yc divided by delta y, right? We are removing these two and writing here. multiplied by minus 1 raised to 1 plus 1.
Sir, for delta, only delta woman, we need not to divided by delta. For z parameter, this is
Yeah, you're right. My mistake. Right? And similarly, you can find out other parameters also, delta 1, 2, which is here. So, yb plus yc divided by delta y. It has been incorporated minus 1 raised to, so delta 1, 2 is minus yc times minus 1 raised to 1 plus 2, right? So that's how it becomes plus yc, and which is coming here, right? So this way you can find out z in terms of y. So this is one of the technique. There are multiple of technique which you can use to derive z in terms of y, and similarly you can derive y in terms of z, right? So I am not going into that, how to derive y in terms of z, z in terms of y. Even the book has not derived it, but if you want to derive it, we can derive it. And there is one table where all the relation between all the parameters have been given. Yeah, any doubt or any?
What is delta y?
Hmm?
What is delta y?
Delta y is determinant. Okay, if I went fast, then you can see here. So from here, delta y is determinant of this matrix. This is our impedance matrix of this particular network, right? Okay. Other than that, there is one more parameter which is left as per book. It's called ABCD parameter. So not anybody can dance, right? So this is known as a transmission matrix. This is very much useful in if you are going for communication engineering. If you want to go to RF and microwave engineering, or if you want to become a good antenna designer, you should use transmission matrix. So this is fundamental for all the people who are going in communication side. So then you should be expert of this matrix. If you want to Y, Z and H, this is very important for all circuit designers who wants to become analog circuit designers. These are very important. If you want to become very good at communication engineering, you should use ABCD, or mainly known as transmission matrix, because you want to transmit something from input to output side, or from maybe output to input side. So generally for transceiver system, do you know transceiver, or the combination of transmitter and receiver is known as transceiver. Transceiver is the one where both the things are available, or it is acting as transmitter as well as receiver. So it can transmit as well as receive. So both sides you want to know what is the input output characteristic, or what is input impedance, output impedance, or what is the transfer function. But when you are doing this, where is it? It follows this particular matrix. Look at this. V1 and I1 are input matrix, or are at input side, and V2 and I2 are at the output side. So A matrix is defined as V1 by V2, or the relation of input with respect to output. B matrix again input voltage with respect to output current. Similarly, C matrix input current with respect to output voltage, and D input current with respect to output current. So everything will have either in one side you will have input, either current quantity or voltage quantity, and division will be the output quantity, right? So that's how it's very much useful for, or the handy one when you are designing antenna, because in antenna how wave gets propagated and it's get reflected back, that has to be checked. That's why like input and output relation is very important. Maybe when you are going to study antenna, those who are uh, very much becoming expert of electromagnetic theory and this ABCD matrix, they can use this theory in communication engineering and antenna. Antenna must be coming maybe after learning communication engineering. You should learn RF. The name of that, what is the name of that course, by the way, Himanshu? Do we have antenna here? Transmission line. Huh? Okay, so the name of that course is called transmission line, right? So if you are interested in designing antenna, then you should go for that particular course where you need to understand these kind of theory, and every day you are going to talk about only ABCD parameter, right? Okay. So a parameter is nothing but V1 by V2 when I2 equal to 0. Should I call it open circuit or short circuit? So I am going to call it open circuited. This is ratio of voltages, so I am going to call it voltage transfer function. Similarly, this one, this is going to be known as short circuited current transfer function, right? And other things are the impedance and admittance. Simply like one is short circuited, one is open circuited, right? All parameters are the transfer functions, and like both are all the transfer functions are linked with one side. Upside is input and downside is output, so all are known as transfer functions, right? And one more thing, by the way,
BNC are not transfer.
sorry,
Transfer functions are in terms of either voltage.
yeah, so it's inverse of this, but still they are calling it
That is okay, but BNC.
what VNC.
BNC.
Oh, I'm telling you, that is what I'm going to define it. Till now I have not defined it. Look at this. That is what I wanted to. So is there any problem in these two? Okay. So my next thing was, if it is C or B, where C is I1 by V2 and this is V1 by I2. So do you know all BJTs, all MOSFETs are amplifiers? They can amplify. You know about this, right? Now, what kind of BJT and MOSFET are? Voltage control current source, current control current source, what kind of? So this is current control current source. The reason is the input impedance is low and output impedance is also low. MOSFET, the input impedance is infinite and output impedance is again low. Sorry,
This side, current control current source.
current is, yeah. So output impedance in both the cases are infinite, but input impedances are 0 and infinity. So if this is the case, what is the input? Input is voltage and output is current. Yeah. So such kind of amplifier is known as transconductance amplifier. Whose output quantity is current, input quantity is voltage. So if I want to find out the transfer function for such an amplifier, the output quantity will be current and input quantity will be voltage, and that is known as not operational amplifier. So there are two kinds of amplifier. One is called operational where one thing I never wrote it, but it's operational voltage amplifier, which you have studied till now, and one is called operational transconductance amplifier, which is also known as OTA, and this is known as op amp, where OTA has output as current and voltage as input. So this is also a transfer function if you are interested in OTA, right? So that way these two are also transfer functions, but one is impedance transfer function and one is transconductance transfer function or admittance. So all circuit designers will not call this one as admittance, but they are going to call it transconductance transfer function. So you can call it right now admittance, no problem. So any problem in this? No? All four parameters, right? Okay. So maybe almost time is over. You have to ask something then, because other things will be like gyrator or transformer, which I am going to cover, and then we will like thereafter there is nothing in two-port network. We are going to solve some of the questions. Yeah. Are you feeling comfortable on this Y, Z parameter all? Just for those who didn't come to my last lecture, just how I evaluated your mid-semester examination, I can tell you that. So question 1 was the transfer function. Those who didn't get the correct answer, but by mistake some like doing here and there, I wrote something called something for an effort, 1 for an effort, 2 for an effort. So I gave some marks in charity for doing something for 2 pages, 3 pages, okay. But who got the correct answer, I gave 4 out of 4. But unfortunately, those who didn't get the correct answer, let's assume that they got 0 marks, but they got some wrong transfer function, let's say 1 marks they got. But on the basis of the wrong transfer function, I evaluated poles and zeros. Okay, on the basis of wrong transfer function. Okay, but there are some of the people who copied from someone, I don't know, and the transfer function was different and poles and zeros were different. So in both the cases they got 0 marks. Okay, so after transfer, like the wrong transfer function, if all the things are correct, those are full marks. For the wrong transfer function, if they have made the correct Bode plot, it's all marks, right? Now question 2 was finding out no, like they should understand some people made zeros as poles, poles as 0, something like that. You can show it to me. I can like it's I give generally uniform marks to everyone. There is nothing like if I am giving one person 1 for an effort, same thing will be available to another guy. I don't give any partiality. So if question 2, if you are including Vn and V out as one of the node, which is not needed by the way, okay, just to know that whether you should include those nodes or not. Look, if you are doing any analysis which is like this, how many nodes do you need? Do you need 3 nodes or 1 node? Right? You don't need 3 nodes. Some people got 9, 11, 11 by 11 matrix. I don't know how I am going to solve that. Right? Aishwarya is one of them. Okay.
You take nodes which are known like 20 volt, 30 volt. If it is mentioned, then we don't include them in matrix.
You should not, like, you should make the optimized version.
So
There are some of the places where it was 0 volt.
In book it was given that except ground we consider all nodes.
But afterwards we need to have the optimized version of that matrix. How to solve that 9 by 9 matrix? Determinant is
we take the nodes which are not known to us. Like,
yeah. So V in V out.
so that's why, like, suppose if there is a labeling 20.
If you are writing the equation, those like V in and V out, if you are adding, those will become redundant one.
I'm asking if instead of like the center node, if it is given one another node is there, it is 20 volts.
Yeah, then you can add it. Yeah. But if it is something like this, if this is 0 volt, you know already it's 0 volt. right? There are many places 0 volt. Otherwise, you will never able to solve something like 7th order filter, 8th order filter, which will have almost like 20 op amps, right? Okay, just for giving you insight how you should use. So those who have included V in and V out, and the number of node like matrix entry is more than 5 by 5, they got 2 marks. Those who got less between something like 5 or something like that, then it's 3 marks. But if it is the optimized one, it's 5 out of 5, right? Question, what is third question? So I believe people should not have any problem, right? There are only few guys who made wrong cut set entry, right? So please read about this. Only few people are there. Otherwise, all got something like 14, 15 marks, right? In this, so all got good marks, right? So question 4 was BJT or yeah. So BJT, only Komal got the correct answer, right? So you can share your answer with others. If you want, I can uh, take the scan copy. I give it to all, right? You solved for us, so right? So she has used a delta matrix method through which she got the correct answer. But still, there are some of the people who tried and got in the right direction, but didn't get the correct answer. I gave some 1 or 2 marks for an effort, right? But there are very few, maybe 1 or 2 in class. The bonus question is the one where it will be checked very strictly, right? Otherwise, like she got 25 marks, but in this was a 6 marker question, by the way. I gave 6 out of 6 for her, right? And that's how she got 31. Right? Try to attempt, okay? So I wrote something to Manpreet's copy also, right? So I gave my messages to all, right? Okay. So please try to attempt. Do not kill your creativity, okay?